Write a function that will solve a 9x9 Sudoku puzzle. The function will take one argument consisting of the 2D puzzle array, and the value 0 represents an unknown square. Okay, Sudokus will be easy, i.e. determinable. So you can brute force them. Okay, logical. Right then, so we're going to get a 2D array, and this strikes me as something where we will likely need to, or we can, recurse. So we could have some generalized solution that over multiple iterations will gradually fill in the board. So the first thing we need to do is to find a position where we can fill a given square. We can then fill the square and then call the function again to find and fill the next square until we filled all of the squares, at which point I believe we just return the board, because we have to return, where does it say what we have to return? Yeah, it should return a solved board. So that sounds like a good approach. The way you generally solve a majority of the Sudoku puzzle is by a process of elimination. So you need to fill out the entire board with the digits 1 to 9, not using the same digit in any given row or column or 3x3 square. So generally you have to look for a place where, by a process of elimination, you can see that only one digit could possibly go at that location. So we need to find such a place programmatically. So that's what we can try to do now. So initially, I'm just trying to extract the data that I need. So I'm iterating over the two-dimensional array with a loop over x and y, and I'm skipping zeros, non-zeros even, because they're already filled out. And upon encountering a 0, I'm just getting the row, which is simply extracting the relevant element using the y coordinate, and the column is just doing a map over all of the rows in the puzzle array and extracting the relevant column. So this resolves to an array of the values in the column, or at least it should. And just here, I've written some code to just map the x and y values to the corresponding kind of quadrant or grid, the square that is relevant for that particular cell. So, for example, this cell is within this left cell. Just spotted that I'd put these values around the wrong way, as I commonly do, because it seems logical to have x and then y, but of course we've got the rows in the first position and the columns in the second position. So just fix that. And of course, another problem that I've just noticed, which is quite a ridiculous problem as well, due to copy pasting. I should be using y here, not x. And with that settled, I can now look at the console log output that I have. So I've got row, column, square x, and square y. So 2 arrays followed by 2 numbers. And that seems to be what we're getting here. So that's good. So we're iterating x first and then y, which means x will be 0 and y will then count from 0 to 8. And the first thing that we'll find is this 0 here, because that's the first thing that we won't skip because it's not a 0. and we'll output some stuff. And on this position then, we've got a row that equates to these values, which matches. So that's doing what we think. And here we've got 56084. So yeah, that seems to match the column. And then we have 0, 0, which are these kind of magical calculated square x and square y values, which are roughly going to correspond to the squares that are relevant for checking. We're not doing anything with those yet, but I wanted to just calculate those values so that we could use them later. So if we move on to the next example, so the next 0 would be here, which is in the third square. So let's just check that. We've got the correct row. We've got the same column we had before. And here we've got 0 for x, which makes sense because we're still in the left-hand column. If you imagine a 3x3 grid of squares, so it would be index 0 in the x and index number 2 in the y position. Seems to check out nicely. Now here, now that I have these square x and square y values which correspond to the square that is appropriate for the given cell that we're checking, I can iterate. Well, I can use that value to calculate the position in the 9x9 grid for, say, the top left-hand corner, and then I can iterate using some inner loops. I may not use loops, like for loops. I may do something else, but essentially I can iterate over the values 0, 1, 2 to kind of process the entire sub square, if that makes sense. I'll write the code and hopefully it'll make sense. Okay, so doing this, x divided by 3, obviously x is currently a value between 0 and 8. And when we do 0, 1, or 2 divided by 3 and do math.floor of that, it becomes 0. When we do 3, 4, or 5 divided by 3, that results in a value of 1. And when we do 6, 7, or 8 divided by 3 and the math.floor of that, that will result in a value of 2. So you can see that this resolves to an x coordinate of 0 for this section, 1 for this section, and 2 for this section. So that's handy. We can use that later as like an offset for extracting the data for the relevant square. So you can see how this is used down here in the x coordinate in this little inner section, where I'm now multiplying it by 3 again to get a value of either 0, 3, or 6. And then we're adding on this x2 variable here. Had to use x2 because, of course, x is used. And yeah, in fact, actually, I could have used x. But anyway, just to keep it clear, this x2 value is going to be either 0, 1, or 2 as well. So using this as the kind of offset value, and then using this inner looping over this 0, 1, 2, 3 allows us to iterate over these 3 sub square elements. And then we do the exact same concept for y. So we iterate over the sub square. And we are currently mapping that to, in fact, I've missed the return. We're mapping that to a value that we're extracting from the puzzle. And I'm just going to edit this to make that a nice one-line thingy. so that's a bit more concise. There. So now I'll quickly test that to see what we get in our output. Okay, yes, I forgot to take into account that this is an array of arrays now. So what we can do, because we're mapping multiple times on this outermost map, we can execute the flat function, which I think will then just make it a single flattened array. Yeah, here. So given the x and y, the square x and square y of 0, 0, this should now contain the values from this square here. So 530, 600. Oh, hold on. It's just iterating the opposite direction. So 560, 309, 309, 008. So now we're in the very fortunate position of having all the data that we need to decide, is there anything missing? So we'll do that next. Raises an interesting question. How do we know when we can fill in a square? So there are 9 possible values that could be in a square. Now, if in our row, column, and square nums array, if we have a reference to 8 of the puzzle, of the values from 1 to 9, then the one that is missing is the thing that goes in the square that we're currently considering. So we just need to figure out if we've got 8 unique numbers across all of the data that we've extracted. And a great way to do that is with a set. So a set will only retain items that are unique. So if we do a spread operation for each of the arrays, so we've got a row, we've got a column, and we have the square nums. Let's just make that all on a separate line, just so you can see it. That should then contain a unique list of all of the items. So hopefully we can just go unique like that and rerun our thing, and we'll have an error. Number 0 is not iterable. It needs to be an array. Okay. Fantastic. So now I think this is outputting the cells that we visited and the unique items for each location. So you should see no repetition in any of these. Now we've got this pesky 0 hanging around, which is a bit annoying because that's not actually one of the items, that represents a space. So why don't we just filter those out with the filter? And I guess you can just do this actually, can't we? Because 0 will be false. Yeah, so in here we should have a set that has 8 items somewhere. Here, look, there you go. So this then tells us at this specific location, because there are 8 that we found in rows, columns, and the square, by process of elimination, 1, 2, 3, 4, 5 is missing. Therefore, whatever cell this is at must be a 5. So what we can now do in the next step of this algorithm is to look for sets that have a length of 8, and in that particular case, we can simply fill in the relevant cell. Okay, so what we're doing here then is we have got our unique list of numbers, and we're checking if the size is equal to exactly 8, if that's the case, then I'm just doing a find on this array of all of the possible values, just so that we can find the thing that's missing in our unique array set rather. So the set has a very useful has method that tells us if the set contains the value, and we'll find the item that is not in the set. And just for speed at the moment, I'm returning the entire puzzle. I'm pretending that we've completely solved it when we fill out a single item, so that we can just check that filling out that item makes sense. So let's just test that. Okay, so of course it's incorrect at the moment, but given the board, let's just see. Yeah, so I think that's the item that we found that is solvable first, and it's been populated with a 5. Now that kind of makes sense, I think, if I just make this bigger, because you've got 1, 2, 3, 4. There's no 5. There's a 6 here, a 7 here, 8 here, and a 9 is here. Yeah, so we know we can fill that one with a 5, which is what is filled out in this board here. So now what we need to do, now that we've got a algorithm that will fill the next thing that can be filled, we can I think, recursively call this function until we've filled everything. So let's do that now. So yeah, I got a feeling it's as simple as just recursing here. So when we find something, we populate it and we recurse again, passing in the puzzle with the now newly populated item. And we'll just keep recursing into itself as we find things until finally the board will be filled. When the board is filled, then we'll do all of this logic. We'll iterate over all of the x and y coordinates, and we won't find anything to do, at which time we will return the puzzle, and all of these recursions will return to the original caller. So I think that should do it. Would help if I could type. Wonderful. Hey, and we've nailed it. So that's cool. I think this could be tidied up a little bit, just to be made a little bit neater. But essentially, that's a good solution, I think. Is the final solution that I went with. So instead of using for loops, I'm just using, well, first of all, I've declared this vals variable at the top, which is just something that I can reuse throughout the solution to refer to the values 0 to 8. So that just replaces some of my for loops, just a stylistic preference, really, because I quite like that this returns true, and then I can have a ternary here, true or false, of course. And in here, what's different? So I've kind of inlined a lot of the variables. So where I have rows and columns and the square nums, I think, just compresses it down a little bit. This looks a bit weird. I've grown fond of using double tilde characters in the place of math.floor. They're kind of roughly equivalent, although pretty horrendously unreadable for most people. So I just chose to put that in for fun. But in essence, it's the same. Yeah, not really much else different. Of course, I didn't really like having the return in the middle of the for loops. just a personal thing. I tend to prefer to have, I don't know, just a gut feel. I preferred it this way, but yeah, it's equally valid other ways, of course. But this is my final solution. Thanks for watching. I hope you enjoyed this challenge. I really enjoyed solving it. If you have any questions, stuff them in the comments, or any suggestions, or you want me to have a look at your solution or a different solution, I'd be happy to do so. Also worth mentioning, my channel is growing. Really quite pleased with that. It's suddenly kind of taken a bit of a upward trend. So I'm hoping that will continue, because I really like serving you guys, and the feedback is great. So if you've got any suggestions for what you would like me to look at, I'm more than happy to listen.